Hi Lokesh, welcome to the class once again. Today, in the last 2 weeks of classes, we covered the basic AWS DevOps demo and then Linux. We completed Git and we have completed Docker and then we completed the Jenkins Sonar Cube as well. Today, we are going with one of the most important tool, which is called Kubernetes, shortly known as K8s. uh, s- like we have seen like in the CI/CD pipelines, we were doing the just a build and we were never executing those runs, right? In most organizations, nobody will be running this Docker containers. They will be using Kubernetes to run the containers. Okay, the reason for the like Kubernetes, it's a Kubernetes is like a container orchestration tool. So see, when we were running Docker, you have noted like we are running the command like Docker run, and then we were specifying the port number, and we were running in a single replica account, right? When I was doing Docker PS, you were seeing only one instance it's been running, but in most of the organizations, do you think that one Docker container will be enough to serve the traffic? Because this is my end application and there is some user is been using that. If you run Docker p run command, so there will be only one replica count, right? It will have like one core of CPU and one GB of RAM. Okay, if it is like a main production app, like any e-commerce website or something, do you think that this one container will be able to sufficiently serve the traffic? No. There will be obviously like multiple users will be sitting throughout the world. Everybody is going to eat my application, but obviously a single pod cannot withstand this load, and there will be multiple jobs as well. So okay, in that case, we were started to use this Kubernetes. Kubernetes, first of all, it's a container orchestration tool. So Docker containers will be there, but uh, like Kubernetes is going to manage those containers. So it will help Docker container to run in multiple replicas, like multiple pods will be running. So we can scale up the pods here, and if any container like any application goes down in the container, the Kubernetes will bring the the application pod back to the online. So these are main features that you can consider, that the use case of Kubernetes. Okay, apart from Kubernetes, these things, Kubernetes has a lot of things like it provides you ingress configurations. Ingress means like when you hit some domain name, right? Like Phoenix, like consider my application running on like Phoenix.com. If I hit Phoenix.com, so in the entry point there will be some SSL certificates offloading should be done. So you cannot have this configuration within the Docker itself. You should be having some web server like Nginx to do that. But in the Ingress, by with the help of Ingress and the application load balancer, you can integrate with Kubernetes. There are a lot of use cases when it comes to Kubernetes. So that's why people started to use in Kubernetes. So like Kubernetes, like how I can do this installation and how I can use this Kubernetes. The main point is like installing Kubernetes. Uh, See how the simple architecture of Kubernetes will be going to look is like this will be master node. Okay, consider it as a M. So obviously it will have worker nodes like like a W1 is there, a W2 is there, and W3 is there. So everything is a machine. Okay, everything you can consider it as a Linux machine. For consider this is my cluster, this is my group of cluster, and we have 4 servers. One of my server is master, and rest of the things are worker loads. So Kubernetes own components are there. Those components will be running here, and it will spread the pods across these different worker nodes. This everything form together as a cluster. That's why we always call this Kubernetes as a cluster. Mm, let me erase this one. Mm. See, so let's come to the PPT point. So for the Kubernetes is actually a open source now. You can use Kubernetes in your local as well. But this Kubernetes is actually now maintained by CNCF. It's a cloud native computing foundation. They are actually maintaining the upgradation of Kubernetes throughout in any cloud platform. We have the own Kubernetes applications. So if you think like Kubernetes are open source and they have a contract with the cloud providers. Cloud provider instance, AWS is a cloud provider. Okay, Azure is a cloud provider. Google is a cloud provider. Okay, so what they do is like they get contact with this KATS by the CNCNF, and then they develop their own Kubernetes in their cloud platform. In the AWS, we call it as EKS. That means Elastic Kubernetes Service. In Azure, it is called as AKS. AKS means Azure Kubernetes Service, and then in Google it called as GKS. It's like Google Kubernetes Service. Just the naming changes, but rest how the Kubernetes functions will remains the same. The rest how you create the cluster and the configuration things will be changing it, but how the functionality of Kubernetes will remain same in all the three cloud providers. So these are our three major cloud providers throughout the world. Um, so why we have to use this managed instance from the cloud? Instead, I can why I cannot like take my own Kubernetes and develop in my local. Even that's possible. Still, most of the organizations are like who were not trusting the cloud, because even though we nowadays we say like cloud is growing like every day, but still some of the like organization they don't trust cloud, because cloud means they don't have the control where they place this data center, or they don't control over this data. First of all, that is something called like data constraints. You're joining back,
I'm disconnected suddenly due to
okay,
network issue.
okay. uh, okay, let me continue the class. So um so
And these three are important one you said.
so each and AWS, Azure, and GCP, like the Google Cloud Platform, are cloud providers. They provide their own Kubernetes managed service. Managed service means they will take care of these things. Or they will take care of the installation. They will take care of these worker nodes, everything. So only you need to do is whatever your application needs, you just deploy them. But in general, in the on-premise servers, on-prem means you have a one machine, right? Like there will be a data centers for any organization. There must be some data center there where they will have like a lot of machines there in the data center. They will be taking care of the electricity, the maintenance, hardware fixing, everything on their own. Okay, so that's like instead of trusting this cloud platform, they will have they set up all the machines in the local and they use it. Even in a on-prem, you can use the K8s, but what's the complexity of using K8s in the local means? So obviously, K8s installation in the local, it's tough because you have to maintain network in between this worker nodes, because K8s supports different kind of networking. You should be integrate one machine to another machine, another machine to another machine. So if any pods running here, it has to communicate that there is a scenario, it has to communicate with another pod running here. So this communication you have to take care, this installation you have to take care, this maintenance you have to take care, this version upgrades you have to take care. So in order to avoid these only, people do not use on-prem creators, they move to the cloud EK clusters. Okay, so So I think that's enough for the Kubernetes intro. Um, let's start. See, this how the Kubernetes architecture will look like. In simple, I started telling like you have one master node. You will have one master node, but you will have different worker nodes. But in the real case scenario, you can in the from the manage Kubernetes perspective, there will be lot of managed nodes itself. Like mean like there will be a lot of master node itself, and there can be different worker node as well. Okay, the difference between the master node and the worker nodes, its gates differ, and the component that it got deployed on the machine. So everything is a machine, but whatever the components that we install in the master and worker node, it make the difference. First of all, if you take the master node, you will be having something called let me back to go hmm, see, this is your control plane. You can call it as a control plane or master node. Okay, master node. You there are different components. The first thing is API server. What is this API server? You see different worker nodes here, right? If I am like going to create any pods, it has to send signal to the master node. So whatever the commands that you type, like similar to the Docker commands that you type, you have like Kubernetes command which is called kubectl. Those commands first reach to the API server. Anything, any operation that happens throughout your cluster, the first entry point on the worker node to get that information is API server. It will be first point of contact to receive that information and read that information, and whatever needed for that operation to be done, it is totally going to take care by this API server, the first point of contact in the master node to communicate with the worker nodes. And there is some the second main component will be etcd. Etcd, it's like kind of a database. Okay, consider like a key value pair, or consider like a database, consider it like a storage space where it will store all the informations about your cluster. So whatever the information is, yeah, like this pod one is running in the worker node one, this pod two is running on worker node two. We have total number of worker node as three. We have this many applications running here. So my cluster started to run from this time. My cluster, I have some failure in this application. So all those informations get stored in the etcd. So once you type any kubectl command, or you do some kubectl like troubleshooting commands, it comes to the API server, and the API server forwards the traffic to etcd and gets the information and displays for us in the GUI. Okay, that's the thing that happens in the background. The third component will be like control manager. So control manager will be once the pods are get scheduled in the in the worker nodes, this control manager is going to take care about this pod distributions. Because what is I've started to use the word called pod. So what is this pod first of all? So the basic component of the resource in Kubernetes is called pod. Okay, we when we were seeing contain Docker, we were started to use the word containers. What is container? Like if an application, we will have some image in some Docker hub, in Docker hub or in any other registry. So we pull that image and we run this Docker container. Okay, similar to that, a pod is this container now is going to run inside a pod. Consider it as a just an outer layer to container. So uh, because why am I asking you to consider this pod as outer layer to container means, both this pod and containers are same, but this container is going to run inside this pod. We will with add some additional configuration, whatever you need to be passed, which will be present at the outer layer of the pod. For now, you just consider this word. The pod is like pod, the spelling. Okay, control manager, once your deployment is done, so it will going to take care where my pod need to be scheduled, those things will be controlled by the control manager. Scheduler means when you type when you deploy the application, it will take care on which worker node it should go, on which worker node this application has to be scheduled. Like consider uh, so in Kubernetes, I'm giving an example. So there is an application called X. Okay, so this application X has to be deployed in the worker node 1. There is application Y. It's there. It has to be deployed only in the worker node 2 because we have a lot of worker nodes, right? There is some requirements to isolate this application. Like application X has to be scheduled in worker node 1, application Y has to schedule in worker node 2. So these kinds of constraints will be taken care by these schedulers. So obviously, when you create these constraints and then you apply it, the scheduler is going to take care about the scheduling this part. Once the scheduling is done, this control manager is going to manage the pods. Manage what is management? If the pod goes down, somebody has to bring up, right? Those kind of operations will be taken by the control manager. So these are the main components that present in the control plane or in the master node, the four main components. Okay, so obviously in worker node, what are the like the components present means here we have kubelet. We will have kubelet. What will this kubelet will do? One second. Ah, so in the worker node, you will be having some component called kubelet. Kubelet will be going to run as a service. Service means like what I will say like when we were seeing the installation of Docker, you remember I was using some systemctl commands like systemctl start Docker, systemctl enable Docker. After I did the apt install Docker, when I do a systemctl status Docker, it is running as a service in the Linux. Similar to that, this kubelet, wherever the worker node is there, the first major component is to kubelet. This kubelet is going to take care of the pod schedulings and everything inside the worker node, and it's going to be act as an a centralized point for other components in the worker node to talk with the master node. Somebody has to talk from the worker node to the master node, right? So kubelet will be going to take care, and it is going to run as a service. So service, what I mean service means, I meant like how we run a Docker as a service by using system technology. You can see this kubelet also. It's going to in this machine, it is going to run as service. And this kube proxy, is like for any whenever we talk about cluster, uh, the cluster points to some networking. Okay, um, because I told when we were having multiple machines and it forms a cluster, this pod has to talk to this pod has to talk to something with this pod. So this networking is there, right? This communication things inside this pod. I have to like inside the worker node there will be some Docker container is going to run. So I have to handle the network traffic there. So everything is going to handle by this kube proxy here, obviously. And then one more thing is like CNI, then when the container network interface. And then you will be having some container runtimes. The container runtime would be Docker here by default. In most of the cases similar to Docker, there are multiple tools out there, but mostly you consider some runtime, the runtime as a Docker here. Docker runtime means inside the pod, what is going to run? We are going to run the container, right? Then it has to support Docker, right? So those Docker runtime also it should be present. So what I told, pod is a outer layer. Inside that container is going to be run. Obviously, in most of the cases, you will be having a single container running in the pod, but there is a in the real time scenario. to scrap the metrics, because the container one is the main application. Whatever the logs that get printed in the container one has to be somewhere transferred to some centralized point. In those, we will run one more container to scrap the metrics from container one and send to some centralized area. So this is what the architecture of Kubernetes. So any doubts in this thing? Because once again, let me complete. See, Kubernetes is one of the most important topic for you to learn, and it has lot of components. In Docker, we were just seeing some command lines or something, but when it comes to Kubernetes, that is not like too much of command lines, but you have to understand the concept. Okay, it's just like some how do you like you writing some theory based papers. You read the content and you keep the concept, right, and you apply the concept. So this Kubernetes is most kind of like a concept oriented. So you have to understand this flow, because later somebody asks you, if I deploying something, how this configuration went to here, what components are there. This the most in most of the interviews, the vast asked question is this Kubernetes architecture, to understand your knowledge. Like, because you can read, obviously read some definitions, but what you learned from that, so that you, once you started preparing that, you will get. So now we will go on. What's your question now?
Uh, QB, what is the QB proxy? I didn't understand.
Kube proxy. So there is something called CNI. There is something called CNI. CNI means Container Network Interface. Okay, it is installed when a worker node is going to spin up. Spin up means when it's going to get scheduled. Uh, this is CNI will be there. Okay, CNI means Container Network Interface. So each and every Docker container, when we were using, when we were running Docker container, when we do Docker inspect the Docker container command, we were seeing an IP to the Docker container, right? You remember when we were doing the Docker, each and every IP Docker container gets an IP, right? So those things, and then and then if the container is running, I have to access this container, right? There is some network traffic has to go in and go out, right? Some obviously I have to access the container, and this container to the world, it has to talk, it has to read some data or something. So these are what, these are network traffic, right? This is controlled by this kube proxy component. Got it?
Okay.
You can just consider it as like the component which is used to control the network traffic inside the worker node. Mm. If you come down to my slides, you see what I mentioned. Like I mentioned the same points whatever we discuss. Control plane manages enter Kubernetes. API means like entry point. etcd means like key value store. Scheduler means unassigned pods, assigning the pods on the nodes. And then control management manages the deployment if any application goes down. And then if it comes to kubelet, see, kubelet only is the point of contact that talks to the API server in the control plane to manage the worker nodes. Kube proxy manage network routing and load balancing. Container runtime means this Docker. Container runtime should be there. So that's how the container is going to run. So this is the basic. I think I covered it. You have any doubts? I believe you don't have any doubts now. Let's move to the next slide. So, um, so when I was initially talking that we will be installing the Docker in the on-prem machine as well. What I told, first what I want to do is, in like, you create a master node. From there you took some configuration and apply it in the when the worker node, and then you take that another configuration, and then repeat the same process in another work node, and do the same thing in the third node. See how much manual effects are there. You have to first create the master node, you have to choose the network, you have to apply those configs in worker node 2, worker node 3. So that's why the on-prem machines are very tough to maintain, because you have to each and every time you have to add some worker node to your cluster. You have to do this configuration, and you have to maintain these networks. This connectivity of these old worker nodes and the master, it all begins with some networking. So the networking, there is something called network plugin. What I told like CNI, right? CNI is container network interference. So in our on-prem, you will get different plugins are there. So each and every plugin has its own merits and demerits. We are not going to cover that. You just need to know. So like in most of the on-prem, they will be having some network plugin called Calico, Funnel, or Cilium. These network options are available for you in the cloud as well. Apart from these networking, these are the common networking that supports the Kubernetes. Um, like Calico is like the basic for managing cluster, whatever like a basic networking setup that is needed, that is provided by this Calico plugin. Okay, when you work, we are not going to cover that, because general installation of Kubernetes, like whatever I told, you configure the master node, and then in this creating this multiple worker nodes, it's begin edit, and we are not going to cover, and nobody is going to ask you about the things. So in those steps, there is a mandatory step for you to install the network plugin in each and every worker nodes in the master node. So the Calico will provide you a basic network software, whereas Cilium will give you some advanced network options. And then this panel is like basic overlay means like it's kind of some um, like how can I say, like when we group these multiple clusters, the funnel mostly used for this engaging these worker nodes. That's a use case of this funnel networks. But you can just keep on remembering the CNI types available are Calico, Funnel, and Cilium. So, and the Cilium as the most advanced networking. But apart from this networking, when you go for AWS or Azure or GCP, they have their own CNI as well. In Amazon, it's like it is like Amazon VPC CNI. It's a native VPC VPC, because what happens like let me go to my PowerPoint. Like uh, um consider it is my cluster. Okay, when you are using this Calico or Funnel or something, what will happen here is like uh, it is my Kubernetes cluster, and it is working in the AWS. Okay, I created a cluster, managed cluster in Kubernetes, and it's running. So consider this a VPC means like a virtual private cloud, and or consider this cluster IP, private IP. When we were doing EC2, we were seeing two IPs, right? One is public IP, one is private IP. So consider the private IP of this one starts with 0.0.0 and slash 16. We will come to this when we were seeing about this AWS cloud. I'm just for now you consider it gets a VPC. VPC means this private IP it's there, right? How this private IP is it gets the private IP from this range only. But when you install this Calico or Funnel or this Cilium, what happens here? The networking inside the cluster will be different. You will not have this series of IPs that assign to your pods, like it's considered pod 1, pod 2, pod 3. If you use other networks, it will start with some other IP ranges, 172.0 or something. Every part starts with different IP address. So this is apart from like VPC, it's actually a virtual private cloud. It's like it will have its own separate private IP address, but these pods running inside the cluster will not get the IP ranges from the VPC. Instead, it will have its own IP ranges, so they can talk to each other. If you always consider, if any application or any service gets an IP address, and with it's starting from the same range, they're going to talk each other and they are isolated. But whereas in case of AWS native CNI, what will happen in see, these are the default CNIs. But when it comes to like Amazon VPC CNI, this time if I use that, it is not going to have that separate IP address. Instead, it will create a public private IP from this range, and it will start from 10.0.0. So now what will happen in this case means you in it consider it as AWS, and it has some EC2 machine here and some database here, and some consider like some database consider as EC2 machine. Now this EC2 machine also got the IP from this VPC address only. It also starts with some 10. It also starts with some 10.1 or 2. Now all these things gets an IP address from the same VPC. So each and every resource can talk to each other. You obviously your pod can talk to your database, your pod can talk to this EC2 machine, your pod can, and the reverse versa is possible. So that's the use case when you have this Amazon VPC. If you feel that your application need to talk to each other, then you will be using this mostly using this Amazon native um, IP addresses. When you use Calico, Funnel, or Cilium, this pod will get different range of IP addresses. Okay, that for now you just understand this one. Um, Now let's move to the actual installation and Kubernetes setup here. Um, as I told, like in order for you, when we come to cloud class, we will be seeing like how we are going to create a Kubernetes cluster from the cloud and all. But now, for now, like we will start using the Minikube. This Minikube is like a like obviously Kubernetes needs some more master node, worker nodes, and a lot of machines are needed to avoid that, and only for some test purpose or for learning purpose we are using this Minikube. It's very easy setup, okay. So and obviously apart like with this Minikube you have to do some more installations called lens and kubectl. Minikube, I told it's a cluster. It's a you download so each and every links I provided in the slide. If you click this if you click each and every links, you or if you do Minikube installation or something, it will redirect you to the Minikube portal where you see installation. You say Windows. Either you do exe installation or you do PowerShell. There is something called PowerShell here in Windows. If you click PowerShell and run as administrator, and then you come back here, and there are some commands here, right? You see some copy thing. You move your cursor here, copy thing will there. You copy it and execute. It will run. It's simple. Okay. Um, so we are setting up a cluster in our local. That's the use of this Minikube. Lens is like I'm giving you advanced class. No, see, in most organizations, see if you run some if you run some applications by command line each and every time, like similar to Docker, you have to execute some command lines. So you have to visualize the thing, right? So that's the thing use case of this lens. To set up this lens in your local, I think you need some um, mm, you need some corporate email IDs. Well, I have some corporate email IDs with me. That's why I'm able to log in. Uh, if possible, try to set up the lens. See what will happen is like if you see this demo k attachments, when I installed this lens, this this cluster was already there. If you open this demo k attach, you see work nodes, deployments, pods. So each and currently none of the application is running. That's why you see it zero. So it's a use case to visualize the application that's actually running in the cluster. That's a use case of this lens. And one more thing is the kubectl. So in throughout the Kubernetes journey, you will be using command something called kubectl. So we know you have to do this kubectl installation as well. I have attached the link here. Once it's done, I will share this entire PPT with you. You can do check this PPT to do the installation and everything. If you do, we will be always in the local. We will be executing some kubectl commands. kubectl apply, kubectl get parts, kubectl check deployments, kubectl logs, kubectl describe. What this kubectl means? This is the basic command line like Docker we seen, right? Docker pull images, Docker images, and then Docker ps -f. Similar to that, we will be using this kubectl. So you have to do these three installations if possible. At least do Minikube and kubectl installation in local. I have done all those installations in my local. I'm just showing you some demo. So you go to this installation page and you copy this PowerShell and open your PowerShell in your local. Um, give this run as administrator, uh, and this copy these commands and come back to PowerShell and keep it and then run. So I already ran it, and my Minikube is running in my local, and the same thing goes for rest of the installation as well. If you click this lens, it's just an exe installation. I just click the download here. I choose Windows ID, and it's a exe download, and then download it, and then kubectl is there. I went on kubectl on Windows, uh, and there is Windows installation is there. Install kubectl binary. It's same thing. Like either you can use this direct download, or you can use some curl commands to download it. Go to CMD or something similar to this PowerShell. Go to the CMD, run as give us run as administrator, and then run these commands whatever it's getting suggested for you. Run this command to have this kubectl get installed, for installation. There are different ways to install on Windows using chocolate tree, or you can go with this also. Multiple options are available for you. See, the throughout your like journey with the DevOps, you will be doing this installation, you doing this configuration, you do this setup, you do this automation. That's how the life of DevOps engineer will be. So you start familiarize with these things. um, so once the Minikube has been installed, I have to type some command called Minikube start. Like if I do Minikube start, is currently running my local. You can see after the Minikube has been running, you just need to open the Docker. I have something called Docker desktop because it needs what the Kubernetes architecture we have seen. Like in the Kubernetes organization, it should have some CNA, right? It has to be installed. It has installed, but it has to run. Okay, so if I open this Docker desktop alone, it will be running in my local. That's the reason I opened it. Now let's see, I have everything is running. Now I started the Minikube. Once the Minikube, it's running the Docker Minikube container. You just give the Minikube start. It will start the cluster for your local setup. Okay, now let's move back. Um, uh,
Yeah, no doubt. Grass or no?
ah,
I have a doubt.
yeah,
Grass now.
yeah, yeah. Please go on.
We are installing in Windows, but we run that from the starting itself. We are installing Linux Amazon only.
Linux. Um, this command you're talking about, this Minikube command.
Yes.
No, no, these are PowerShell commands. Okay, so I have some. Let me
Okay.
explain you something. See, mm, I think I explained it already in one of the class. Um, no issues. Let me explain back. Like, uh, see, if it is a Linux machine, okay, you will be running something called shell script or Python. What I told the shell script means, you put all the Linux commands in the shell script and you run execute the shell script. Okay, when it comes to Windows, you cannot use the same shell script to run it in the Windows. Okay, obviously in the Windows you will be using PowerShell only. Most Windows supports PowerShell scripts only. So these are some PowerShell scripts commands. If you come here, say, see, download and run it in the latest dates. or use it using the PowerShell. That in your computer you have something called CMD, that means command prompt, and then you have something called PowerShell, and then you have Git Bash. If you have installed Git Bash, Git Bash will be mostly support some Linux functionality as well. So um, and then if you take some Python application, Python can run in anywhere. It can run in Linux, it can run in Windows as well. So you got the difference. It's a like some just a shell interpreter for you to run.
Okay. Uh, I think I will ask afterwards at the last. Okay.
Okay, okay, okay. Um, now let's start the basic class. See, once my minikube started, see, I'm actually running it in the Git Bash. I opened the Git Bash and started the minikube start. Now my minikube is started to run. See, this how the output logs will be. See, currently Kubernetes 1.31 is running. That is the recent version that of Kubernetes. It's mostly like 1.33 something. Now that's not an issue. This how the output logs will look. Once it's done, what I told to use kubectl commands. Kubectl version first. You see, the client version is like 1.31, server version is 1.331. So what it means like my Kubernetes version is like 1.31. The my minikube I did minikube installation today. I did this kubectl version installation long before, so it's showing it as a version 1.31, and the server version means this minikube version is 1.33, which is the latest one. Uh, that's how the that's what's the output of this kubectl version command, and then. mm and then something called the basic command for you to execute in the Kubernetes like kubectl uh, get pods. You see what it says? No resource found in the default namespace. So let me explain the scenario. Um, Obviously it's a cluster, right? We have different worker nodes or something. Leave that behind. Okay, leave it here. Like it's in the cluster only. I'm just keeping the worker nodes here. But now you always start to visualize the thing in a single box. Okay, whatever the pods that you schedule here, all of them actually going to be in a single cluster. Okay, consider it's a cluster, and all the pods are running going to be running in this cluster only. No, you don't consider behind this worker nodes where it got scheduled or something. Now all the pods are there in your in your application, in your organization. So you will be having different clients and different environments. So how the DevOps life cycle is going to be like, when we were seeing this Git branching itself, you will get some idea. There is some branch called dev, right? And there is and another branch will be future, and there another branch will be release, and some other branch will be master, and some other branch will be bug fixes. These are branching strategies. Okay, you leave this behind. Okay, because each and every branch we will deploy in different environments. That's what mostly how it looks like. You will be, once your changes are done, you will be deploying in this is environment, this is branching strategy, this is environment. First we will deploy in dev, consider our server. First, we will deploy in dev server. Then we go to QA server, that means quality server. Then we deploy in UAT server. UAT means like pre-production. Okay, before the production, there must be something is there. Once the application come here, the QA team will give UAT sign off, and even once in QA, they have to do QA sign off. So if they give the sign off only, they are approving that your changes can go from this environment to this environment. Once it come to UAT, it has to go to prod environment. In production itself, mostly you have one main production environment, and there is one more production environment that in some of the organization they will run it in parallel, or they will run it in one more prod, like consider it's a prod, and one more environment is DR, that means disaster recovery. What will happen if my production environment goes down? somewhere you should have the application running in parallel related with the same configs of production. If something goes down, end user will be not routed, traffic will not be routed here. Instead, the traffic will be routed to this DR region. That's the meaning of the environments. See, these are the multiple environments for any organization. That's how they maintain the environments. Dev environment, QA, UAT, prod, and DR environment. So when you start to run every environment in the um, like in a single pod, so to maintain the isolation, there is something called namespace. In Kubernetes, you create a namespace. Whatever the dev application is there, you run the application in the dev namespace. If QA is there, you create a namespace. It's like an isolation for you. You deploy the QA, and there is one more namespace called UAT. You run the UAT here. Mostly all the non-prod things will be running in the same machine with some isolation. Mostly prod clusters will be different. Cluster non-prod means this dev QA and all non-prod. You can do whatever activities you want. You do test and you deploy your changes. Cluster prod is serving the traffic to client, so we should not disturb them. So here we have one more name server for production where application is deployed. So in order to you bring this isolation, we have something called namespace here. You create some namespace and do the segregations. So by default, whenever you do kubectl get pods, it is going to be in some default namespace. When the Kubernetes is installed, if you go to this command line, if you do kubectl uh, get ns means I will type full command stuff, namespace. Okay, you see, when I install this minikube, these are the namespace that already present in the system, uh, and some of the applications are running there. Okay, these are default namespaces. But when you type kubectl get pods, what it actually means, it's trying to fetch the pods that running in the default namespace. These are some system oriented pods that running in the Kubernetes. If you do kubectl get pods hyphen n, hyphen means namespace, and then default. See, no resource found. This both the commands are same. kubectl get pods and kubectl get pods hyphen name points to the resources that's running in the default namespace. If I do kubectl get pods hyphen a means in all the namespace. Whatever the four namespace you see, now I want the pods running in all the namespace. Then you will be seeing, you see in the kube system, we in the kube system namespace, you see first column is namespace and the name and what is the status, it is running or not, from how long it's been running, when it got restarted, what is the status of it, it's ready or not. You will see the entire status here. That's the basic kubectl command. The first you will execute this kubectl namespace or something. Now for me to create one namespace, I will be running running command called kubectl create namespace dev. So now it what says namespace dev is created. If you do kubectl get namespace, you will see that dev namespace is created for me. Now see, and then there's something called, we'll come to our rest of the things now. And then something called, now for now you just understand, we have something called kubectl namespace and we have something called kubectl pods. Let me come back to my project here. I have created a KTS project here. Mm, mm. Why I'm actually opening this project is like, for any resource that we deploy in Kubernetes, there are two ways to deploy. Either you use command line or you use something called or you use some manifest files. So if I go to my browser and then I do see KATS means Kubernetes pod manifest. I type pod manifest and then you enter. You come inside this thing. You go to this section. See, mostly you should get familiarized with accessing these documentations. Mostly, if you want some reference, you will be just checking it for the initial period of your learning. You just you see there is some configuration, right? Copy this, and then I'll do like I'll create a pod.YAML file. It's an YAML file. So the file format is in YAML file. Okay. I just copy it and paste it. Now you see there are four main sections here. The first section is API version. You have to mention this API versions you don't have the control. So each and every time you go here in the pods manifest section and you have to see what is the API version that Kubernetes releasing it on the releasing for the pod. You have to see the version. The first section is API version, API and the V is capital, and the second thing will be kind. This kind mostly reference here when I was opening this demo creators, you are seeing right pods, deployment, daemon sets, stateful sets, config map, secret, what type of resource you want to create. Because in Kubernetes, n number of resources that you can create, different types of resources. What kind of resource you want to create? I want to create pod. And then in the metadata section, you just give some name as nginx. Metadata means it just some additional non-working parameters that you are giving to uh, your application. We know nginx means like it's just a name. Okay, in Kubernetes, in Docker containers, at the last to give any pod container any name, we were specifying like hyphen name, and Phoenix we were giving the container as a name, right? This metadata session is used to give some name to the pod. Okay, and then in the spec section, the most important section will be like spec section actually contains some technical details for your container. In the spec, you have some container section. In the containers, you having a list. The list would be like for you have to understand something. Wait, let me go back. Hmm. Uh, for now you just consider in if you are done some coding or something, what you call list is means some series of entries, 1 dot 2 dot 3 dot or 4 dot. This how you've been considering as a list, or you will be considering list as like you open some square brackets, the first index and the second one 2 0 3. So this how you've been your totally was considered in the list. And then what do you call dictionary, uh, and something called dictionary is there. Dictionary means key value pair. um, Key value means like my name is equal to Manoj, and then like uh, native is like India, and something like that, right? So the first entry contains the key value pair, the second entry contains the key value pair, right? So in YAML, this YAML is mostly contents of this list and dictionaries only. The content that you see in the YAML file, it's always list and dictionaries, and some other type is available called list in dictionaries and dictionary in list. Both are possible. Okay, so but the for you need to consider these things only. List means it will be looking like this. Dictionary means it will have some key value pair. Now I come to my manifest file. Now see API version equal to v1, it is a key value pair, it is a dictionary. And then you come here, kind and pod, it is a dictionary type. And the metadata session, you have name and uh, like name, and the value is nginx, it's a key value pair. And then if you see this section I called as list in dictionaries. Okay, you open spec section, you open the container section. In the container section, a list has been opened. A list in dictionaries is there. You see, um, not dictionary, a dictionary in list. Dictionary in list means it's like a list. One, two, three sessions are there. but there we have a key value pair. A name is equal to nginx, and image is equal to this name is like the first name, the name for your pod. This name specifies the name for your container. The second name is the actual image that you are going to run. If you specify nginx 1.14.2 means the what image that you have to run, and container port means what port you have to run, and inside the port it's again again a dictionary in list. You see containers port is equal to, it's a key value pair, right? So throughout your this Kubernetes journey, you'll be seeing this list dictionaries and listing dictionaries and dictionary in list. Throughout this thing, this entire context is going to be there. So either to create an pod, you can use this manifest files, or there are some imperative commands that you can also use to run the pod. First, let's see how we what we did is like we went to this the Kubernetes.io, which is like Kubernetes documentation. So in this Kubernetes documentation, you can see for all the resources that we were seeing, you can get this documentation and the manifest file syntax here. Okay. Now what I do is like I am redirecting to K8s. Now what I do, we know kubectl get pods. There is no namespace, and then if you could say name, uh, I'm just checking whether I'm in the same cluster, and yeah. So we created dev namespace before. Now what I'm going to do is like I'm just going to run this container. What command I have to use means kubectl apply -f, and then give the file name. What is my file name? If I'm actually in the K8s directory, if you type lsf you can see a pod.yaml is there. The pod.yaml file is there, and then you run kubectl apply -f pod.yaml. What is this? Pod engine is got created. Let me check kubectl get pods now. When previously I was running kubectl get pods, it was saying no resource found in this namespace. While if you type this namespace, what happens? A container is getting created for you. So and then let's wait for the container to come up. Now the container is started to run. You feel how to after you applied the script get pods, you have to see the in once the container start to run, you will not seeing the complete details, right? If in case you want to see the complete details about this pod, what's the configuration of this thing, you will do something called kubectl describe pods, and then give the pod name nginx. Okay, because I know where nginx pod is running, you give the command called kubectl describe pods, and then nginx means, see it will give you a complete detail. You see the name is nginx, the namespace is in default. If you obviously if you don't provide the namespace, it is going to run in the default. That's why I called, if you want to segregate, you provide the namespace that we will see, and then uh, service account is default, and then you see the image is like nginx 1.4.2, and then you see and then you see like it started the container, successfully pulled the images, where like what is the volume for this one. So you will see the details. By when if you want to see the details of the container, you have to use the kubectl escape command. It is similar to the inspect command in the Docker. Okay, now what I want to do is like my pod is running, you made some mistake, okay, or you have to modify the container name or something. What you have to do is I want to edit. Either what you can do is like you can edit this file. Okay, see what I'm going to do is like instead of nginx, I give something called phoenix. I give it my container name is phoenix. Okay, when I was typing here, you see I don't see the name here. See in containers, I'm seeing the section called Nginx, because uh, previously the container name was Nginx. I don't want the container name to be Nginx, and the pod name also I don't want to be like Nginx. I giving as a I want the pod and a container name to be Phoenix. I changed the name from to Nginx to Phoenix now. What I do is like I again execute the kubectl apply command. Okay, once I did the pod command and after you do kubectl get pods, what happens here? Like what it says, kubectl nginx is running, but now kubectl Phoenix is also running because what happened here is like um, it considered the same resource. Um, what happened here? Like uh, here it considered whatever the resource I created, it considered it as a separate one, and this a separate one. That's the reason you see both the resource now. So then now I can rename this thing. That's the thing. If you see for the existing running application, if you want to rename, there is some command called kubectl edit. Uh, there's some command called kubectl. Let me come the kubectl um, edit pod, and you know what's your pod name is nginx, right? Let me modify with nginx. uh, Straight away it is going to open you some editors. So if you have VA editor, if it is Linux machine, it is going to open your VA editor. Now what I do is like I go here, I instead of nginx I'm giving as a nginx 01 in the container section. You see I am coming inside in the metadata section. I have nginx here. I am giving it as nginx 01, and in the container section also I have the name as nginx. I have replaced with nginx 01. You see, in both these places, updated instead of nginx, I saved it as nginx 01. Now I just save the file. 7, close the window. Oh, very I'll change the content name as 01. It's not saving for me. Wait. Okay, you leave it. It's because right. Uh, You see, the names was not able to edit. But what I did is like when I did, if you want to edit the same thing, I did kubectl edit pod and I changed the image from 1.14 to 1.15 here. So you can use this command kubectl edit to edit the resource directly if you instead of editing in the manifest. If you have to edit the resource directly, you can use this kubectl edit command. And the next command would be like um, we know like if I do kubectl get pods, um, I know if Phoenix is running. How I know it was triggered by this kubectl manifest file. If you want to feel that you want to delete it, you use this kubectl um, delete file. Hyphen f means here it's not a force, it means a file. Okay, hyphen f means a file, and then if you do delete means now and Phoenix pod is deleted. If you do kubectl get pods, now see only the nginx is there. Now if in order for me to delete this nginx because I don't have the manifest file for this one, like if I want to delete it, what I should do is like kubectl um, delete pod and then give the pod as nginx. What I'm doing, I'm deleting the pod. Now if you do kubectl get pods, now see the pod has been deleted. So this is the basic use case of kubectl commands. We will starting with other resources by tomorrow. Lokesh, you have any doubts here?
No, Satish.